Hello, space enthusiasts. For centuries, humanity has looked up at the starry sky and asked the same question. Are we alone in this vast universe? For decades, science fiction has promised us alien worlds that could host life. But science has lacked clear evidence. Everything changed when we sent one of our best eyes into space, the Kepler Space Telescope. On July 23, 2015, NASA held a historic press conference, where an announcement was made that shocked the astronomy world. Astronomers had discovered an exoplanet so similar to our own home that it was immediately dubbed Earth 2.0, or Earth's older cousin. The planet's official name is Kepler-452b. Today, we'll embark on a long journey together to the constellation of Cygnus to uncover all the secrets of this mysterious world, to understand how much it really is like Earth, whether life is possible there, and what it tells us about the future of our own planet. To understand the significance of the discovery of Kepler-452b, we first need to understand how the Kepler telescope works. Planets don't emit light of their own. They are incomparably small and dim compared to their bright stars. Seeing an exoplanet directly is like trying to spot a mosquito against the light of a lighthouse. That's why astronomers use the transit or shadow crossing method. When a planet passes in front of its star's disk, it blocks a tiny bit of the star's light. It's like a fly flying in front of a light bulb. The shadow is so small that the human eye cannot see it. But the Kepler telescope's super-sensitive sensors record this slight decrease in the brightness of the light. If this decrease is repeated at regular intervals, then we are dealing with a planet orbiting its star. The Kepler mission has discovered thousands of exoplanets, but most of them were either gas giants like Jupiter or were too close to their star to become lifeless rocks. Kepler-452b was a completely different story. Kepler-452b is located about 1,400 light-years away from us. This means that the light that reaches our telescopes today from this planet began its journey in the early Middle Ages, when humanity on Earth was still forming the foundations of modern civilization. The first thing that fascinated scientists was the star of this planet, Kepler-452. In astronomy, the habitability of a planet depends largely on the type of star it orbits. Most planets in the universe orbit red dwarfs, small, cool, but extremely aggressive stars that frequently emit powerful radiation flares, destroying the atmospheres of nearby planets. But Kepler-452 is not a red dwarf. It is a G2 star, just like our Sun. It has almost the same temperature, the same chemical composition, and is only 10% larger than our Sun. This is an extremely rare find. We had found a planet about the size of Earth orbiting a close sibling of the Sun. The second incredible factor is the planet's orbit. Kepler-452b is located in the habitable zone of its star. In astronomy, this is often called the Goldilocks zone. This is the distance from the star where the temperature is neither too hot nor too cold, allowing liquid water to exist on the planet's surface. And here's the most amazing fact. A year on Kepler-452b lasts 385 days. That's only 20 days longer than on Earth. The planet is about the same distance from its star as Earth is from the Sun. If you were to stand on the surface of this planet, the star rising in the sky would be almost indistinguishable in size and brightness from our Sun. Now let's talk about the physical parameters of the planet itself. Kepler-452b belongs to the class of exoplanets that scientists call super-Earths. This means that it is larger than Earth, but smaller than Neptune or Uranus. The planet's radius is about 60% larger than Earth's. Although astronomers cannot weigh the planet directly, computer simulations show that its mass is about 5 times that of Earth. This is an extremely important indicator. A mass of about 5 times greater means that Kepler-452b is most likely a rocky planet with a dense core, mountains, volcanoes and, possibly, oceans, rather than a gas giant. If we were to find ourselves on such a planet, the first thing we would feel would be the force of gravity. The surface gravity on Kepler-452b is about twice as strong as on Earth. This means that if you weigh, for example, 70 kilograms on Earth, you would weigh about 140 kilograms on Kepler-452b. Your muscles and bones would have to withstand twice the weight. If life exists there, the organisms there would likely be shorter, have stronger, thicker skeletal systems, and stronger muscles to withstand that weight. But there's one factor that makes Kepler-452b not only exciting, but also a little scary. It's its age. Our solar system and Earth are about 4.5 billion years old. We are in the prime of our star's life. Kepler-452 and its planet are about 6 billion years old. That's 1.5 billion years older than our system. What does this mean for the planet? As G2 stars age, they gradually become brighter and hotter. Kepler-452 is now 20% brighter than our Sunday. That means Kepler-452b is getting 10% more energy than Earth gets from the Sun. Astronomers believe Kepler-452b is a glimpse into the future of our own Earth in 1.5 billion years. As its star heats up, the planet may be entering an extreme phase of the greenhouse effect. If the planet once had oceans, the high temperatures could have caused them to evaporate. Water vapor, a powerful greenhouse gas, traps heat even more, setting off a chain reaction that could accelerate the process. This could mean that Kepler-452b, which for billions of years was a perfect haven for life, is now gradually turning into a dry, hot world. On the other hand, if the planet has a stronger magnetic field and a thicker atmosphere, this could prevent the water from completely evaporating, preserving conditions suitable for life in certain regions of the planet, such as the poles. This raises the most important question. Is there life on Kepler-452b? If you think about it, 1.5 billion years is a huge time for evolution. Life on Earth arose about 3.8 billion years ago. If life on Kepler-452b started at the same rate, then the organisms there had 1.5 billion years more time to develop than we have. If there was a civilization there, they could have reached a technological level that is even impossible for us to imagine. They could have adapted to the changing climate of their planet or even abandoned it, moving to other star systems. Scientists from the SETI Institute, Search for Extraterrestrial Intelligence Institute, have already pointed the Allen Telescope Array Radio Telescope System at Kepler-452b, trying to catch artificial radio signals. So far, there is silence. But this does not mean that there is no one there. Perhaps their signals have not yet reached us, or they use completely different communication technologies that we do not yet master. Could we ever visit Kepler-452b? Here we are faced with the harsh reality of cosmic distances. 1,400 light-years may seem like a small number in the cosmic scale, but it's incredibly far away for human technology. The speed of light is 300,000 kilometers per second. It takes a beam of light 1,400 years to reach Kepler-452b, the fastest spacecraft we've ever built. Voyager 1 travels at about 17 kilometers per second. If we were to direct Voyager 1 to Kepler-452b, it would take it more than 25 million years to get there. The next time you look up at the night sky, look for the constellation Cygnus. Remember, they're 1,400 light-years away. A planet orbits an ancient star. Perhaps right now, someone out there is also looking up at the sky and trying to see our sun. Thank you for watching. If you enjoyed this journey into the depths of space, don't forget to click the like button, share the video, and subscribe to the channel so you don't miss our future cosmic discoveries. Write in the comments whether you think there is life on Kepler-452b. Until we meet again among the stars.